Good day, weather technology students. In this video, we're going to talk about the introduction to hand analysis and see some examples of how we go about doing this process that many meteorologists do every single day. And so we've been talking a lot this semester about plotting maps, but now we want to take it that step further. We want to then start to interpret these observations that we see on the maps by then drawing contours on them. And so contouring is done in 4, quote unquote, easy steps, right? Now, easy is maybe a bit trivial here, but we're going to show you it's not too terribly hard, but it will take practice to get better at it. And so these 4 easy steps that we're going to go into in detail. One is first drawing lines lightly in pencil or doing it electronically if you wish, as we want to constantly correct the analysis as we go along. 2, we want to make sure that whatever analysis we do is going to be meteorologically consistent. Finally, next to last, we're going to need to label our contours properly, and then finally, in the end, ink them in or finalize them, as we would say. And so first, we're going to start with drawing lines lightly in our pencil, right? This is where we're actually doing that initial analysis. And what we need to keep in mind when we're doing this initial analysis is that what we are doing is we are interpolating the data, right? We only have limited observations, and we're going to see an example of some surface temperatures here in just a second. And we need to be able to interpret between the points. Never, ever, ever do we want to extrapolate beyond those points. And we'll see what that looks like in just a second. And ultimately, you may need to go through a couple of iterations to make sure that your line represents reality. And so here is an example of a surface map over kind of the greater Midwestern area with surface temperatures. And we want to be able to decipher all these values, which is kind of overwhelming to look at, by putting in contours to see in general what the pattern of temperature looks like over this region. And so we're going to start by identifying 50 degrees. These temperatures are in Fahrenheit. And so what we want to do is we want to find every area that is 50 and basically connect the dots. And we see we have a couple of 50s on here, right? We see a 50 there, a 50 there, a 50 there, and a 50 there. But there are a whole bunch of other places likely on this map that are 50 degrees, and we need to interpolate based on it, right? And so we see here that we have values between, say, 49 and 52 along the Iowa-Wisconsin border. We know that 50 would fall in between there and would likely fall a little closer to 49 than 52 because it's only 1 degree away. So we might say that our dot would be maybe right around there. Right in between 49 and 51 along the Lake Michigan coast there, right smack dab between the two, right there. And then in the end, what we're trying to do here is then connect the dots between all of these different locations. And label our line as 50. Right, so that's pretty easy. We could try another one, 60, right? 59, 61, dot there, 60, 60. Let's see, 60 all the way down there, 60 there, 59, 60 right in the middle there, a little closer to 59, 57 to 64, just a touch closer to 57, 60, and then 62 kind of right in there. And so then we go ahead and connect the dots. And then again, we label it as 60. Now, through time, you should hopefully not have to do the dots, but you can think about the dots in the middle. And so let's go ahead and do 40 here, and I'm just going to freehand this one. So we're going to go 40, 40 and up there, pretty close, 40 up there, 40, 40, 40, and that's our 40 line. Right? We could do a similar thing for 30. Looks like it's right up here at the top. Get rid of our little banner there. There's 30. Notice how I'm labeling these contours here. And again, this is the first pass. I might go back and refine them later. No units on our contour labels. And then we can maybe do our 70 line, kind of coming down here, going up 70 and across. And that's 70. Right, and so now we see this gradation in temperature because we've drawn in these contours. So we see drawing contours not too hard. We could actually even do an 81 down here, 80 down there. Again, it takes practice to do this well. And again, we'd want to refine these through time, whether doing it electronically or by hand with paper and pencil. And we want to beware of bad data points. So, for example, this was from homework number 2. We see that there's this bad data point over Lake Michigan. Now, we don't want to actually take that into consideration when we're, say, doing a temperature or pressure analysis here, because it is so out of whack with all the stations surrounding it. So what we want to do is we want to just put in, you don't need to circle it. I circled it here just for the purposes of the video. Just do a light X right through there so that we know that we're going to ignore that point, and then just don't consider it in the contour, and we can do that. And that's okay. And as you get into looking at your data, you'll notice sometimes when maybe it's just the temperature that's off, so we don't include it for temperature purposes, but we do for others. And there's any number of reasons that would be the case. The next thing we want to do is we want to make sure that our meteorological analyses are consistent. And so specifically when we're doing things like upper air maps, which is where we're going to start our journey on hand analysis, remember that the flow in our upper levels largely follows our contours of heights for our winds. And so those things are very closely related. So we would want to make sure that the height lines we're drawing are then parallel to the wind that we're seeing. There are any number of these relationships that we could use. For example, geostrophic wind balance or gradient wind balance in the upper levels, where then our wind is flowing parallel to our height lines. Troughs tend to tilt towards cold air, so we're going to see colder air in the center of our troughs. Ridges tilt towards our warm air. We're going to see warmer air in our ridges. And that jet streaks are over low-level temperature gradients, and also where we have large gradients in our heights aloft. All these things, right, should be taken into account when you consider the different things going on when you're doing a hand analysis. That's what's going to be part of that iterative process of making good hand analyses. Finally, then, we're going to need to label our contours, as we talked about in our example there. And then some information about labeling here. Generally, we're going to want to use decameters on upper level maps. So instead of 5,400, 5,400 would work well. Same thing would be true for all maps. And so here it's slightly different than what our height decoding is in. We always want to use decameters for the labels there. If you're at the surface, generally 2 digits is enough for those surface pressures, just so we don't have large values there that we're contouring. The label color should be in the same color as your contours are. Temperatures typically in red, heights are in black, and so on. And do not put units on the labels. No units. Stop the units. No units on the labels. Okay? And then finally, if you're doing this by hand, inking the contours at the end means taking permanent marker and going over those lightly done contours in pencil to ink them in and then erase your pencil marks at the end. And so finally making those contours permanent, doing a final filtering of your data, making any necessary refinements, adding shaded if necessary or desired, and again, erasing any of those errant pencil marks if doing it by hand. So you're in your handout, there are all the common upper level parameters that we would both contour and then the common intervals there. And pay particular note here. These are good resources not only for your hand analyses, but also for your plotting of contours later on in the semester of gridded observations. So for example here, we have our contour information for height for 500 millibars. It's every 6 decameters or 60 meters, centered around 540 decameters. So the proper contour levels would be 528, 535, 540, 546, and 552. You could go both above and below those, adding 6 decameters or subtracting 6 decameters as we go out from that 540 marker. The color of our heights are black. The line style is solid. Temperature is typically every 5 degrees C on the 10s and 5s. They'd be red and dashed. Often at 500 millibars, we would plot wind speed. Every 20 knots on the 10s, starting at 30, would be blue and dashed. Or if you have meter per second, which can happen on maps, although typically for this particular course, we're going to use knots. That'd be every 10 meters per second on the 5s, starting at 25 meters per second. That's so we don't have to contour all the way down to 0, because often there are winds that are faster than 30 knots or 25 meters per second, and so we're just plotting the faster winds with our contours. You may also shade on 500 millibar maps. Typically the isotax or the wind speed are the isotax are what would be shaded, with progressively darker shades of blue to purple, beginning at about 50 knots. Again, the shading here is more of a suggestion. As long as the shading looks good and consistent, that is what you would want to do. And so here is an example of a 500 millibar map that we might contour. In a separate video, we'll go ahead and show an example of contouring this map by hand. That's it for this video. Thanks for watching.